to this video on complex analysis. I've been requested to do a question on residue theorem, and the question reads: determine the residues of the function f of z is equals to 1 over z squared into bracket z plus 1. So when you are confronted with a question like this, the first step you need to make is to determine the singularities or the zeros. So we are going to have our denominator is equals to z squared into z plus 1 is equals to 0. So we can either say z plus 1 is equals to 0 or z squared is equals to 0. So z is equals to minus 1 for the first part, and z squared is equals to 0, so z is 0. And this one is not a simple pole. In fact, this is a pole of order 2, and this is a simple pole. For z is equals to 1 is a simple pole. Now we have a way in which we determine the residue for a simple pole and for a pole that is not a simple one. So let us get the residue of f of z at z is equals to minus 1. Okay, so we do it by taking the limit as z approaches negative 1 of z plus 1 multiplied by f of z. This is equal to limit as z approaches negative 1 of z plus 1 times 1 over z squared plus 1. Okay, so you notice that this z plus 1 and z plus 1 both in the numerator and denominator will cancel. So I'm left with limit as z approaches negative 1 of 1 over z squared, and this is 1 over negative 1 square, which is just 1. Alright, so the residue of pole at z equals to negative 1 is equals to 1. Let's get the next residue. So residue of f of z at z is equals to 0, which is a pole of order 1, a pole of order 2. We are going to say is equals to limit as z approaches 0 of z minus 0 quantity square over z minus 0, that's just z squared, of derivative. Of course, it is now first derivative, because if you have a 0 of a pole of order n, then you're going to perform differentiation n minus 1 times. So we are going to have 1 over z minus 1, the function we are going to take the derivative for. When you do that, you're going to have limit as z approaches 0 of derivative of 1 over z minus 1 with respect to z. So what is the derivative of 1 over z? That is negative 1 over z minus 1 quantity square. So we take limit as z approaches 0 of this function. So this is going to be equal to minus 1 over 0 minus 1 quantity square. So this is going to be minus 1 over negative 1 square, that's 1. So the answer is minus 1. So we have determined the residues for various poles, and as I have said earlier, that